the rubbery one. Okay, so right now we got the observer connected USB to the tablet, and we've got it configured. So we can get that serial number on. H8 or AHFOFB.
It's crash bar. Crash bar.
I went up to the crash bar in the front. Okay, so we're recording right now. All right, close her up.
It's gonna go in between there. This on this side. Not to pull the cables as much.
We're good.
They're all in.
Oh, give me a little bit of slack here. Alright. That way it can bend down a little bit there and not be.
Okay. It's got it closed, so we're not gonna pop open.
Okay. I think it should be set to go right now. Got it.
In 1080,
1080,
30
yeah.
frames per second.
Yep. Let me get. Okay, it's recording now. Yeah. Hold on. All right, go ahead. And then wait for us when you get out there, okay? You know, 30, more video than anything.
Okay, so let's say you have a GoPro mounted to a mount, and you're seeing a good amount of linear vibration.
Okay.
I mean, the most I'd typically expect you to see is plus or minus a quarter of an inch, right? Of just pure vertical movement. And let's say you're recording a bike off in the distance 20 feet away. The most that the frame's going to move up and down is a quarter of an inch linear if the camera is just moving up and down linear. And that's what your accelerometer is recording, right?
Mm-hmm.
That's what you're assuming is happening. But if you were to look at the rotation of the camera, the micro angular vibrations are actually causing the image to move up and down much further than just this linear quarter of an inch up and down. And you know, when
it's exasperated by the distance, and
the further away the subject is, the more that angle is going to affect how much the frame's moving up and down. So just to give an example, the equation is just a cosine equation. And you're 20 feet away, and let's say that the camera is just moving 0.1 degrees, which is that's pretty conservative.
And again, that's just it's in a rotation.
Just in rotation.
Yeah.
Well, assuming that that linear vibration is actually rotation, which often is the case. So 0.1 degrees is what the camera is rotating about your point here.
Mm-hmm.
That 0.1 degrees is going to translate to about 1.3 inches at 20 feet away versus the plus or minus a quarter. And that's just assuming that's a comparison.
Okay, so we're going to go ahead and measure for this rotation, and how we're going to do that. We're going to instrument it with two sensors.
Yep. You have an input and a response accelerometer. You measure the distance between the two accelerometers and divide by so you'll measure the distance between the two, and then subtract the acceleration of the input from the response. Then you just get the difference, and then divide by the distance between them, and you'll get the angular acceleration.